has been made mandatory for the engineering to do in your career in aircraft. So either you can be a designer, design, or you do repair. For design, you will be working for the manufacturer. If you're working for later on, you're working for Boeing, Airbus, so that is OEM, original equipment manufacturer, where you have to do the design. If you work for the airlines, such as MAS, Asia, and the rest, you will be doing the repair. Okay. So what is stress? Stress is very simple formula, sigma, or sometimes they put F, which is force over area. Area cross-sectional perpendicular to the force. Force also, you can say it is equal to load. Okay, load. Force over area, a load over area. So this is the stress. Okay. So this is stress. And remember, you have to do stress analysis. So everything you do to do the stress analysis will be just dividing force over area. So that is what the main activity in doing stress analysis. Very simple. Okay, the tricky part is the main problem is determining the forces. So that is a very critical area. In the most difficult part is to determine the force. Without the force, you will not be able to get the stress, because you have to have the force and you have to divide by the area where the force is acted, then you will get the stress. So it's very simple basically. What you need to what you need to know the force, you need to know the area, you divide force over area, and then you got the stress. Any question up to this point?
No, sir.
Okay, good. So this is review number 1. Okay. So just keep to this. I'll save this and give it to you. As well, I will save the videos and pass it to you later. So that is the first important thing you need to know. And this is the motivation. Because whatever you do here will be used for the future work. Okay, second part. Now we got the second problem. We have the problem. The problem is how to get the force. Okay. The problem is how to determine the forces or the loads. That is the tricky part. How to determine the forces and the load. For this example, we have a frame, a beam that attached the wall. Imagine this is a wall here. Imagine this is a wall. Okay. Here is a wall. Normally wall we symbol as solid here. And then we have installed a beam CB, which is a rod, and a rectangle AB. And then we hang something, which is 30 kilonewton of load. Maybe a lamp or light or whatever, which is hanging from here. Imagine it's just a lamp. Huge chandelier, for example, hanging there, which is 30 kilonewton. Then the problem now, what will be the material? What will be the suitable material and sizes for the rod here and the rectangular beam? This is circle. Circle we always refer to as rod. Rectangular we refer to as beam. So how to do the sizing? We have to translate all this load to the every member. And when you got the value for every member, you go back to the formula, force over area. And you got the stress that you get here, you compare to the material strength. If it is higher, this part will fail. If it is lower, then the sizes, whatever you put, you determine to design this is good. Okay, now, what is the first thing you need to do to determine the force? You have to establish a free body diagram. So, free body diagram, we are looking at static equilibrium. When we talk about static equilibrium, all the forces, all the moment will be zero. The forces and the moment will be zero. So that is the first. So you have to create a free body diagram equation with the thought of everything will go to zero. So the moment will go to zero. The moment at C, the moment here. Anything that force acting 90 degrees to C will create a moment. So AX, which is 90 degrees to C, will act on C. So AX time 0.6. So AX time 0.6. It is positive because you have stated that any moment clockwise, counterclockwise will be positive. So AX time 0.6 will be acting this way. So this is anti-clockwise. Another one is the 30 degrees F. 30 degrees is acting on C. So it's here. 30 kilonewton acting on C here. So 30 times 0.8. And this moment will be clockwise. So that's why you got minus here, negative. So 30 times 0.8, which is negative. Any other moment? C, CX, CY acting on C. Okay, no issue. AX acting direct on C. No issue. So you only have AX and 30 Newton acting on C. AY is direct to C, so no moment. So we have this. So we solve the equation. We got AX is 40 kilonewton. So AX here is 40. So AX here already, we got already the solution. This is 40. So AX is 40 means that anything, the beam here is also 40, which is equilibrium. If we got AX 40 going this way, we have another 40 going this way. So it is 40. Okay, now we got AX. We have AY, we have CX, we have CY remaining to be solved. Now we create another equation. We create the equation, every force, okay, every force per parallel, horizontal, okay, this is horizontal, X horizontal, okay. So we have AX, we create positive, we say positive if we go to the right side. So AX is positive, plus what else? Plus we have CX, also positive. So AX positive, CX positive because we're in direction, and go to 0. Everything is 0. Do we have anything along the x-axis? No, only CX and AX. So we have CX equal to minus AX equal to 40 because 40 is AX is 40. So we got CX here is minus it is 40 degree. CX minus 40. That is only minus 40 mean actually it is in the direction to the left. Because we say positive CX, but the answer is minus, so this CX is acting this way, to the left. So we have CX is minus 40. So we have AX, we have CX, we have left with CY and AY. So we have make equilibrium equation also for in Y direction, we have CX, AY and 30. So we made the equation AX going up because we say up is positive, AY positive Y plus CY, and 30 is minus, going down is minus 30. So AY, CY minus 30 equal to 0. But however, we cannot solve this. Okay, we cannot determine the equation. We cannot solve the equation. Now we have to think how to solve it. How to solve it? Then we go into the, we choose another point. We have chosen C, and it's a moment. Now we choose another point, it's a B. B is a moment. So moment A B, who can act at B? AY. AX? No. CX? Yes. Sorry. CX is yes, but we know already. CY? Yes. So we are having AX, CX, and CY to the B. 30 kilonewton? No. Acting direct. So we make another equation. We use the same convention. Counterclockwise is positive. So moment AB is only AY. Okay, AY time 0.8. Since AY time 0.8 is going to the clockwise, is a minus. So as we create this equation, we know already we can solve AY equal to 0. And then we put in the equation earlier, which is AY plus CY equal to 30. Now we solve this equation, AY become 0. So CY become 30. So we get all. Now we got AY 0, CY is 30. So here is 30. So we saw everything. We got all the value. We got AX, we got CX, we got AY, we got CY. When you got that, you can determine, you need to determine what are the forces along this. And we know already the forces of CX, CY. So we can conclude by having the what is the component force along the CB and along the AB. Along the CB, we have to do a bit of calculation because ABC along the BC is the result of CX and CY. CX is 40, CY is 30. So CX is 40, CY is 30. So we have, what we have is this. So this is 30. Along this is 40. And we do the theorem Pythagoras. And for the BC equal to 30 square plus 40 square and square root. Okay, so we got BC equal to, what we got BC equal to? BC equal to 30. Okay. Any questions so far?
Sir. Sorry sir.
Yeah.
Kenapa kalau force tu kan, moment tu, kalau dia counter clockwise, apa dia positif
Itu kita punya decision. You boleh go the other way, tapi kena consistent. If you want to go clockwise positive, you have to use the force summation. Force also all to the left is positive. Then you got the same answer.
macam ni?
Okay, you can have, wait So if you want to use, you can use again. You can use the component positive. However, the forces Fx to the left positive, and then Fy is positive. If you do this analysis, you have the same answer. So this is just your selection. Either you want to choose clockwise or counterclockwise to positive, or you want to choose pointing to the right or pointing to the left is positive. The answer will be the same.
Oh, so kira direction tu tak kisah lah, kita sendiri decide lah.
Yes, but don't mix.
Okay, thank you sir.
You don't mix. So this is one set.
Right.
This is one set, and this is another set. But you don't mix. Any question? Any questions so far? Okay. What? I made a mistake somewhere. Sorry, I think I made a mistake earlier. I made a wrong statement. Okay, the BC is here. Yeah. This is a C. This is B. Okay, how to get this answer is a 30 square plus 40 square, which is equal to BC square. Okay, let's go back to basic. So BC square, I just do step by step for you be able to see. So, which is 30 is 900. Plus this one is 1600. So BC square equal 900 plus 1600 is 2500. 2500. So to get the BC, remember you have to square root the 2500. So BC will be 50. Okay, this answer. So BC here is 50. Or you can make a simple ratio rule, is also okay. But however, I show this for you who are not really able to see directly. I show you step by step how to get the value of BC from the value of 30. Okay, 30, because 30 here is a CX. Okay, 30 is CX. Okay, CX is 30 and CY is 40. Okay, sorry. This is wrong. Okay. What we have here, we have CX 40. This is what we got here. So CX is 40. Okay, it's 40. Is 40. And CY is 30. That's why we resolve it CY, CX, and then we use theorem Pythagoras. This one will be 50. Any question? I'm not going to go back because after the midterm break, I will do the midterm exam for you. And I'm not going to repeat again because I did repeat this many times. So if you got any question, you can ask now, and then I can go to the next one. Why I keep repeating this, because the core of the activity will be determining the force, and you must be able to know how to determine the forces. Okay. The rest is simple. After you get all the forces, you know now already forces here. AB is 40, BC is 50. So here is already know AB here is 40. BC here is 50. So those are the forces that acting on this beam. forces acting on the beam. So for you, if you want to know what are the stresses, so this action, all the forces here along the beam, this is axial force. So axial force. Axial forces, which will give you axial stresses. So what you need to do is, you have to go back to the first thing that we have learned earlier, is stress equal to force over area. So area of the rod is, area for the rod is round, which is pi r square, and the other one is rectangular beam. So let's skip how to calculate the area. Just accept what has given here is this value here. So the force now BC, 50 kilonewton over the area. Area, the cross-sectional area. Okay, the cross-sectional area around here, the cross-sectional area of the rod, you got the stress of 159. So for BC, you got 159 mega Pascal. And you need to compare. With the strength. Here. That make the rod, which is you make from steel. It is 165 megapascal, which is, okay, now we compare. So now what you get is 165 megapascal, which is where the material is made of, and what you put the force of 30 kilonewton give you the stress of 59 megapascal. So the material stronger than the stress due to the 30 kilonewton, then this rod will not fail. Question? So remember, from the first problem, you can see the problem is we have a rod, we have a beam attached to the wall, we apply 30 kilonewton, we resolve the forces to each members. Step 1, step 2, then you end up with the forces of each member. From the forces, you can determine the stresses, and you compare to the material that make the rod and the beam, and looking at the calculated stresses, use the material stress, then the part is still safe, so the structure will not fail. So whatever we do in stress analysis, this is what you need to do. This is what the stress analysis is all about. To determine the stresses from the load applied to the structure, from the force, determine the load, from the force, determine the stress, from the stress you compare to the material, what material made of, and you determine what the stress the material can carry. You make comparison. If the forces give you the stress lower than the material stress, then the structure will not fail. If the stress, the applied stress give you apply force, give you the stress, higher than material stress, then the structure will fail. That's it. This is stress analysis. So whatever you learn, whatever you do in this mechanics material, just for that. So that is review 1. So please remember this. Please try to understand this. If you don't understand the rest, if you have difficulty in understanding what are the rest, if you understand this portion of the mechanics material, is very good already for you. Because now you have the understanding what is stress material, how to study the stress of the material, and what are those results for. Okay, questions? Now we back to basic. Okay. Okay, let's have a for 10 minutes. We come back at 3:30, and then we continue with the rest. You want to go this slowly during the break. If you are still having anything that you are not clear, you please let me know. I will go and repeat it. I really need you to understand this part. It's very important. That's why I keep repeating this, because I found out many students after the end of the class still do not understand what is stress analysis and what are the procedure methods for you to conduct the stress analysis. That is where, I mean, you don't achieve the course, the intent of the course. Okay, thank you. We'll just have a break and then we come back again. 3:30.